For the purpose of our tutorial, all the footage we will use is from one of my favorite movie-related resources on the web, hollywoodcamerawork.com. You will find the link in the description text. When you get to the home page, go to the Downloads menu and select the Tracking Plates link. Please read the really important text first and then scroll down to the Object Tracking Plates and download the Blaster Walk High Definition plate and the Survey Shot High Definition plate. This particular footage has a non-square pixel aspect ratio and may seem squashed, but that's something we will deal with inside Cinema 4D's tracker. Let's prepare our project folder so that everything is nice and neat. On your hard drive, create a folder called Blaster Walk Tracking. Go inside and create a TEX folder, and inside that move each image sequence folder after you have downloaded them. While you're downloading the footage, please start watching the next video where I will explain how a motion tracker works. Having a deeper understanding of the technology will allow you to shoot footage that works better with a motion tracker and will make your life much easier and your FX shots much higher quality. Cinema 4D's motion tracking has many tools associated to it: menus, tags, palettes, and a dedicated layout. Let's get an overview of all these, just so that we know what is where. In our standard layout, first of all, we have the motion tracker menu. Most of the stuff we will need is there. Then we have some tags. They are located in the Motion Tracker Tags submenu. The two main objects of the motion tracking workflow are the Motion Tracker object and the Object Tracker objects. Then, from the Motion Tracker menu, select the Motion Tracker Graph View. The graph view is a dope sheet that allows us to see all 2D tracks over time, their quality, called error, their speed, and their acceleration. These values allow us to judge the quality of each track and filter accordingly. Finally, we have the motion tracker layout. This layout has most of the tools you need to do motion tracking. Now that you know pretty much where everything is located, let's look at some of the specifics. Over the next few videos, we will see the attributes of the motion tracker and object tracker objects. 2D trackers come in two flavors, automatic and manual. This distinction has nothing to do with how they work, as all trackers do exactly the same thing: record the pattern in one frame, search for it on the next frame, and therefore record a 2D trail of the specific image feature. These differences are the following. How were they created? Who chooses the original placement? And what happens when they lose the pattern? As far as the creation and original placement are concerned, automatic trackers are randomly generated on a frame of our shot, and any of them that happen to be on a high contrast area are kept, while the others are deleted. With that original position as a start, each tracker tries to follow the feature underneath it for as long as it can. On the other hand, manual trackers are placed by the user on parts of the image we think are good candidates for a tracker to follow. As far as what happens after the pattern is lost, the automatic trackers just stop recording 2D positions, whereas the manual trackers expect the user to manually realign them if the feature is still available, or tell them to stop recording. Automatic tracking is a very straightforward process and comes with some interesting attributes for creating and filtering. On the other hand, manual tracking is much more labor intensive. Since the manual tracking process has a semi-automatic component, it's referred to as supervised tracking as well. But I essentially mean exactly the same thing. In this video, I will tell you the opposite of what the title suggests. I will tell you what you need to avoid in order to get the best possible shot for motion tracking. As we all know, filmmaking is an art form, so I don't expect you to follow all the rules when you're shooting your movie. Just make sure you avoid any unnecessary mistakes. Also, make sure your survey shot is perfect. So, let's see a list of some of the things you need to avoid, the most important ones. Number 1. Avoid jittery camera motion. Use a Steadicam or dolly if you have access to one. In the movies, they usually add jitter and shakes in post. Number 2. Avoid fast moves. Try to keep it as smooth as possible and don't sneeze while shooting while you're at it. Fast moves introduce motion blur, thus blurring the images. Also, most modern prosumer and low-end professional cameras have a rolling shutter, whose distortion effect is very obvious in fast-moving shots. Number 3. Avoid a lot of moving objects in your scene. Our tracker is capable of filtering out moving objects, but if there are a lot of them, it certainly doesn't help. For example, if your scene has a lot of trees swaying in the wind, or a city street scene that has a lot of cars going by. You get the idea. Number 4. Avoid heavy depth of field, as it distorts the way things look. Number 5. Avoid anything that introduces visual artifacts. High compression, low resolution, non-uniform noise, for example in low light situations using high ASA. And number 6. Make sure your shot has enough parallax. Shots with very subtle movements may not be able to provide enough information for the tracker. Now you have a general idea of what to avoid when shooting a scene you intend to track. If you adhere to the above rules, your life will become much less complicated. In this tutorial series, I will guide you through the discipline of match moving from start to finish. If match moving doesn't ring a bell, maybe you know it as tracking, as in camera tracking, and object tracking. If you still have no idea what I'm talking about, just search on Wikipedia for the term match moving and you'll get your answers. This series doesn't require any previous match moving knowledge or experience, but requires some understanding of the filming process of live action shots. Nothing fancy, just basic stuff. For the viewers that have some experience already, you can skip to the section that shows the interface, tools and workflow inside Cinema 4D. I'll post the exact video name in the description text. Having said that, I suggest that you at least skim through the first videos just in case. So, what is match moving? Match moving is the process that allows us to extract motion data from a live action shot and apply that data to a 3D camera and 3D objects so they match the motion of their counterparts in the live action shot. Let me explain this using the source footage we will be working on during this series. Once upon a time, somebody took their camera and shot the following scene. After going through the process of camera tracking and then object tracking, we successfully replaced the prop with a cool looking 3D weapon while retaining the correct position of all objects relative to the camera. The majority of blockbuster movies you see in theaters these days have had some sort of match moving process involved. By using Cinema 4D's match moving toolset, you'll be able to add a new level of magic to your live action shots. The whole process of match moving is a testament to human ingenuity, but comes with a few challenges. In order to do match moving successfully, you need to have properly shot footage and patience. Although it isn't. Welcome to match moving in Cinema 4D. The object tracker object is the object that holds all the trackers associated to the specific object we're trying to track. If your shot has more than one object to track, each object needs its own object tracker object. Too many objects, but unfortunately that is a terminology. Let's take a quick look at the attributes. In the Trackers tab, we have a link to the motion tracker that holds all the associated data, including the footage and the camera solve. The object tracker simply cannot exist without a motion tracker, even if the shot has a static camera. Underneath that, we have a link to a geometry object. This is used in geometry-assisted tracking, but I will not be showing this workflow in this series. Then we have a list of all trackers that define the specific object we are tracking. These were originally tracked in the motion tracker and then selected and assigned using the buttons below. Any tracker that has been assigned to an object tracker is excluded from the 3D camera solve as it doesn't provide any useful information about the camera motion. Name, search size and pattern size are the object tracker's equivalent settings we saw in the motion tracker. Each tracker can have a different set of values, and we can set these interactively in the viewport as well. In the Reconstruction tab, we can lock the solved data for the specific object so that we can proceed to tracking another object in the scene. the two settings in the very long named group, Settings for Geometry Assisted Object Tracking, are irrelevant as we won't be showing any geo-assisted tracking. Of course, right at the bottom we have the most important button. Run 3D Solver for Object. When pressed, the object trackers will be evaluated against the camera solve and the object motion will be calculated. With this video, we have concluded the overview of the attributes of the tracking the survey shot. As you saw in the previous video, with the help of the focal length we extracted from the survey shot, we were able to track the camera very easily and rather successfully, I would say. Because some of you may not be convinced yet about the usefulness of the survey shot, as it requires a bit more effort, let's quickly take a look at what would have happened had we not used the focal length and tracked the shot with unknown and constant focal length. Let me remind you that the focal length was estimated 34.51 millimeters, and we should expect something close to that in this case. Mind you, I'm using exactly the same footage and exactly the same tracking settings. So let me just go here and say full solve. So the solve is finished. Let's select the camera and take a look at this. 47.773. So this is 13 millimeters more than what was calculated earlier. And I have to tell you, it took a bit longer to solve, and that is because there was less information available. Now let me just double click here, copy this, and I have another document. What you see here is the camera that was estimated. I'm going to make a copy of it by control dragging, and I'm going to go and activate it. What I'm going to do is paste this number here. Now look at the difference between these two. That's quite a significant difference, and even if we correct for distance, let me go and do this. So let's select this, move it over here. Let's see, there you go. Look at the difference in perspective. This is what I want you to pay attention to. So the size is similar, but the perspective is different. This amount of deviation in the focal length is going to produce a very wrong result. So I really do hope I convinced you that a survey shot, when available, is extremely helpful to have a very quick and very successful and accurate solve for your camera and object. In this video, we will wrap up the attributes of the Motion Tracker object by looking at the Reconstruction tab. Here, you define parameters relating to the 3D solve. For any of this to make sense, you need to have a good 2D track. The Reconstruction sub-tab allows for selecting the solver algorithm. We will only use a default full 3D reconstruction in this series. Underneath that is where we set the focal length parameters for the tracked camera. The little menu has three options for focal length. The default unknown but constant means you have no clue what the focal length is, but you know for a fact that no zooming occurred during the shot. For your information, when you zoom in or out, you're actually changing focal length. The larger the focal length, the more the zoom and vice versa. When using this setting, the camera lens focal length and sensor size will be calculated automatically by the tracker and applied to the solved camera after the 3D solve has finished. So I repeat, for fixed lenses, or if you know that there was no focal length change, this is what you must select. Moving on. Unknown means no clue whatsoever, which means that either there is zooming or you can't be sure. If the footage to track was given to you and no other information is available, my advice is to go through the footage and try to estimate if any zoom is occurring. Then decide which setting to use. The last setting, known and constant, is what you'll select if you know or have estimated the focal length. Just so that you know, minor deviations from the actual focal length value will not impact the 3D solve too much, but it's better to be as accurate as possible. The grand Run 3D Solver button at the bottom is it. Press that and the 3D solve will commence. After the 3D solve has completed, each 2D tracker gets a null assigned to its respective three-dimensional position. Don't forget, although trackers represent two-dimensional positions themselves, they correspond to a 3D position. That's what this whole tutorial is about after all, transforming a bunch of 2D data into 3D. With the display settings, we just define the shape and size of these nulls. Each null will inherit the error color of its respective 2D tracker. Green is good, and red is, well, not so good. There is a small setting I left for last. It's the lock solved data, and it's very important. Here's when you should activate it. A 3D solve relies 100% on the 2D tracks you have created, the specific 2D tracks, and any camera parameters you have used. If any of the previous things changes, even a single tracker, then the whole 3D solve is invalid and will have to be deleted and recalculated if you press Run 3D Solve again. Now, the object tracking workflow can be done after the camera tracking, and actually that's what I will teach you to do. But that entails that you will add some new trackers to the shot, the ones you will track the object with. So this setting instructs the tracker to keep the solved data, camera, nulls and all, regardless of the changes you will do. So after you're happy with the 3D solve, activate it to avoid any unnecessary data loss before you start tracking the object trackers. So this concludes our overview of the Motion Tracker object attributes. Let's move on to the object tracker now. In this video, I will explain what a survey shot is and why it's so important to the match moving process. In order for the motion tracker to do its job better and provide us with a more accurate 3D solve, it allows us to feed the 3D solving algorithm with the camera lens focal length. If you have your lens spec sheet, you can probably find the focal length, but there's a problem. The named focal length of the lens itself is not the actual focal length of the lens camera combination. The actual focal length is calculated by multiplying the lens focal length by the focal length multiplier, which is derived from the sensor size or something like that. Just to get an idea of how large the discrepancy is between named and actual focal lengths for different sensors, just search for focal length calculator on the magnificent web and you'll see what I mean. What is the solution then? Well, simply let the tracker calculate it for you. But immediately you would ask me, why did we go through all of the above if we could calculate it in the first place? Well, here's why. This is the shot we are going to track. And let's play forward and you will see that although it's a pretty stable shot, we have certain things which don't help the tracking process. For example, we have this girl in the foreground. We have all sorts of things in the background which don't provide us with great accuracy. And because these are trees, maybe there's a bit of a breeze and they're moving around and so forth. We have a background that hasn't had any handmade trackers added to it, so we have to rely on whatever was there to do the tracking. So what I'm trying to say here is that when you're shooting your movie, you cannot adapt your artistic flavor or your storyline to cater to the algorithms of a motion tracker. That's not the way to do it. What you can do, though, is the following. With the same equipment, and when I say equipment, I mean the same camera and the same lens, go and shoot something that doesn't have any of the problems that this shot may have. Let's go here and I'll show you the survey shot that was shot for this particular shot. So the same person that shot the previous movie, he actually just did this. He put the prop on the floor, he added a few bricks, he made sure there are some tracks here, some features that will help the camera. They have good contrast and so forth. And what's going to happen is that when we track this scene, which is a very easy scene for a camera tracker to track, we can then extract that information and then go and feed it in the solving part of the reconstruction. We're going to talk about this later on. But that is what a survey shot is. It's a very sterile scene that is catered for motion tracking that will allow us to extract some information, providing you use exactly the same material. So please, don't go and shoot your survey shot with a different lens, a different camera, or a different focal length, and then put that number in a scene that's been shot with different equipment and expect anything good to come out of that. In some cases, you may even use a survey shot to extract the 3D shape of your prop. As you can see, this prop here is exactly the same one that's been used over here. And because this is moving, it will be more difficult to extract its shape and dimensions from this scene. So you can go and do it here. So the two main reasons for a survey shot is to extract some information about your equipment and possibly even making a 3D model from your prop and use it to add it to your main shot. In this video, I will show you what is a good tracker, what is a bad tracker, but I'll show you nothing about ugly trackers. I just wanted a catchy title. The ideal shape for our 2D tracking algorithm would be a square noise pattern that doesn't change size, orientation, or perspective. Unfortunately, you won't find these ideal trackers very often, or at all for that matter. In real-world scenarios, you only really need to concern yourself about the manual trackers, as the automatic trackers will find their own patterns to sit on. As far as the manual trackers are concerned, we set the manual tracker and then press a button to tell it to track. When the track loses its focus, we correct it, rinse and repeat. But here's the not so good news. There are times when you will have to adjust the position of the manual tracker on every single frame for quite a few consecutive frames. So having a shape that allows for accurate placement without too much speculation is necessary. In my book, small spheres and pointy things are perfect for that job. The spheres, because regardless of their orientation, always look like circles in 2 dimensions, allow for the placement of the pattern square aligned to their bounding edges, and that tracker will give us the center of the 3D sphere. This is ideal when using them for object tracking, as you can choose those centers to align your 3D objects. The pointy things, on the other hand, are ideal for tracking larger areas, green screen backgrounds, etc., as you can center the tracker on the tip of the point with relative ease. Be prepared though, sometimes seemingly good manual trackers will fail to track miserably for reasons that seem unintelligible at the time, but are actually very logical. A change of size or orientation, perspective skew, change of contrast, and other things do make the tracked feature look very different from the original one, and can therefore throw off your tracking. In those cases, a deep breath and some fully manual tracking will get you going, with patience and tenacity being your best tools. The good thing is that 7 good trackers will get you a very good 3D track. That's the absolute minimum. Add a few more for safety and the overall work shouldn't be that much. But be prepared nevertheless. The most important thing is track quality. 10 very good tracks will yield a great 3D track, whereas 100 not so good tracks will fail totally. Talking about not so good tracks brings me to the next subject. What are bad features? The most common cases are the following: reflections and speculars. Often, bright dots and patterns caused by reflections and speculars can fool the tracker, as these tend to move with your camera rather than fixed on your surface. Obviously, these tracks won't help the solve. On the contrary, they will confuse the tracker and sometimes lead to bad solves. Beware, these little buggers show their face more often than you think. Wooden tables, for example, have a varnish finish but are bumpy. Any reflections or speculars will produce very jittery tracks. Second, we have overlapping objects. Sometimes what seems to the tracker to be a nice pattern to follow is not a fixed point in space, but the result of 2 different objects overlapping in 2D space. In this case, the tracked point is totally useless, as it doesn't represent any usable information. It's just a visual artifact. Lastly, randomly identical areas. Sometimes the tracker can be fooled and jump to a close-by area of the image because there was some similarity in the pattern. Just like above, these can throw off the solve. These jumps can happen on consecutive frames, so you may see the tracker bouncing here and there. That's a very bad track. There are remedies for all of the above. Bad tracks can be identified most of the times using an array of provided tools we will see in detail later on. Now you should have a rough idea about tracking and trackers. Knowing these things will definitely make your life easier when tracking. And since I was talking about making your life easier, in the following video we will see what a survey shot is and why we need it. The 2D tracking tab is dedicated to, well, 2D tracking. This is the process of generating, tracking and tweaking the 2D tracks and can range from fully automated to fully manual. Let's focus on the attributes now. In the Automatic Tracking tab, we can see the settings for the generation and tracking of auto tracks. Number of tracks and minimum spacing defines how many automatic tracks will be generated and how close they can be to each other. Although initially the auto tracks seem to be generated randomly, actually the algorithm places them on high contrasting features of the current frame. Auto-replaced lost tracks is a function that adds more trackers to the scene when the previous ones are lost, either because the feature exited the frame or if an object obscures it. This setting guarantees a healthy number of tracks on every frame. Create auto tracks creates automatic tracks for the specific frame you're on. We use this when we feel that at a specific frame the automatic tracks are not sufficient. Then we have the big button named Auto Track that has two arrows, one on each side, and then two separate arrows. These buttons do different things depending on the following condition. If there are no automatic trackers in the scene, you know, the ones you created with the Create Auto Tracks command, this is what's going to happen. It will first create a bunch of auto trackers based on the above attributes, number of tracks, minimum spacing, and auto replace. Then it will load the footage into RAM, and finally it will track bidirectionally, which means forwards and backwards, or in one specific direction if you selected one of those single arrows. And after these operations are done, you will have a full 2D track to inspect, refine, and do a 3D solve. On the other hand, if you have any auto tracks already created, it will load the footage and run the 2D solve without creating any more. Mind you, if you're adding your own automatic trackers, the auto replace lost tracks won't do anything. In this case, you should advance to another frame and add more auto trackers. Delete auto tracks deletes either any selected trackers or all automatic trackers in the scene if none are selected. Finally, the filters allow us to filter based on 4 rules. Filtering means hiding and ignoring the tracks because they are of bad quality and will lead to a bad solve. Minimum length will ignore tracks with less than the set number of frames. Maximum acceleration helps filter out trackers that jitter suddenly, which sometimes means that it has jumped to another feature. This parameter basically compares the previous distance to the current and decides if there's too much of a difference between them. If that's the case, the algorithm assumes it's because the tracker jumped to another feature, which essentially invalidates the track. Error threshold deletes tracks whose error is above the set value. The error is defined by comparing the recorded pattern and the current pattern. The bigger the difference, the higher the error. Lastly, the smart acceleration works alongside the maximum acceleration, but takes into account the motion of the neighboring trackers to identify if a track jumped or if the camera just did a sudden motion. If the camera did do a sudden motion, that will make all neighboring trackers move in a similar manner, therefore considering them valid. The Manual Tracking tab has the equivalent buttons but for manual trackers, to track bidirectionally, forwards or backwards, and for deleting them. Underneath, we have a list of all our manual trackers, a renaming field, and parameters for the search size and pattern size for each selected tracker. Finally, the Options tab is where we set pattern and search size for automatic trackers, some display options, and the Extrapolate search position. This is a setting that I have found little use for, so just ignore it. The last setting is for adding the object track name to any manual tracker that has been assigned to a specific object track. Since we can have more than one object trackers in the same scene, it helps to know which of the manual trackers belong to which view of the 2D tracking tab. In the following tutorials, we will see more of these in action. Very often, especially during manual tracking, you may need to trim your tracks. Trimming is a way to tell the tracking algorithm to ignore a feature for a specific number of frames, rather than risking the tracker picking up on a random pattern by mistake. Trimming occurs naturally when a feature exits the frame or hides behind another object, but sometimes it's something we need to do manually. Now again, we are in our camera solved scene. I'm going to get rid of my cubes and get rid of my constraints just for clarity. Select this and let's go and see an example of trimming. So let's go and select a feature where we lose along the way. There you go. So if I want to track this little feature here, you can see that at some point it disappears completely behind another feature. So we don't really know if it's here or here or here or here. And that may create some issue with the solving if we do that. But with trimming we can solve this problem. So let's go to a frame where we can actually see it and press Command left click or Control left click to create our new manual tracker. I'm going to place it here and of course bring up my motion graph view. Fantastic. And what else do I need to do? Yes, dock this. Excellent. And then rip off the menu. Now if I press H here, you will see that we see everything. So I'm going to select all auto tracks and hide selected and press H, so we have our nice little keyframe here. So let me select it and of course track bidirectional. So let's wait for this to process. It will take a couple of seconds. Fantastic. Let me lock the view and tracks and see what happens. This is exactly what we want to avoid. Although it seems to be a good tracker, if I go here, I press H, you will see, yeah, the error is high, but it seems to be active, and then it deactivates over here. And let's go the other way, and this happens again. Okay, let's fix it for this part, for the forwards motion. So insert key track position, and it's going to automatically update the tracks and move forwards. Excellent. And insert key track position and move forwards, and insert key track position and move forwards, but it doesn't really work. So what I'm going to do here is go to the last frame I consider valid, which is this one over here. And let's go and see what the graph view says. It does give us a relatively good solve up to this point. That's where it jumps. Good. So I want to tell the tracker to ignore this particular feature from here onwards. All you have to do in this frame, you right click and you say trim track, and it has that little scissors icon. If you trim track, what it does, it trims towards the direction where we don't have a keyframe. So from this point onwards, this particular manual tracker will be ignored for the solve. Let's go and see if it appears again clearly. In the future it doesn't, so we can ignore it in that direction. Let's go backwards now and do the same thing for the backwards motion. Let's go. Oops, there it jumps. Excellent. Let's go and insert key track position. Let it calculate a bit more. Oops, there you go. I think this is the best frame to go and trim it. So as we are now, we can go here and right click and trim the track. So you can see now we have two trims, one on this side, one on that side. And again, the choice is made based on where we have a keyframe. Let me show you how to recover. Now what I'm going to do is move backwards and see if at any point this particular feature appears again and is useful to us. And let's assume that, yes, here it is. All you have to do is go here and move your invalid tracker to a valid position, and you can see the calculation resumes. And if we look at this, what you will see is that it does the bidirectional tracking as it should. And there you go. At this point, I don't want to calculate between this and this. Right click and trim, and automatically the algorithm is going to identify the area between the two trims and is going to ignore that feature. Excellent. So now what we have here is, let's rewind, we have this feature that is tracked up to this point, then it gets ignored. Just forget about where the ignored tracker is, it's red so we don't care, and it picks up again. So this is the way you're going to use the track trims to define areas of features where we don't know exactly where they are, and so they don't interfere with our calculations. We just tell them to ignore it. And that is trimming tracks. Let's begin our detailed look at the user interface, the tools and attributes involved in the motion tracking process. To do any motion tracking inside Cinema 4D, we first need a motion tracker object from the motion tracker menu, and here it is. We can load the footage by selecting the motion tracker and going to the Footage tab. If I click on the three dots, I can navigate, go to the folder that contains my movie or my image sequence, and just double click on any one of the frames. The image appears squashed because it has a non-square pixel aspect ratio. Square pixel footage will load without distortion, but either way we'll deal with this in a moment. Let's look at the rest of the attributes. Underneath the footage, you can see the lens profile. Here we will load a lens profile if we have one. If we don't, we just leave it as it is. The resampling settings instructs the tracker to load the footage at a lower resolution. Although it's advised that you always use 100%, there are many shots that can be tracked at lower resolutions. This saves time and memory, especially for ultra high definition footage. For our tutorial, I'm going to use 100%. So let's do that. And you can see now the image is much crisper. Then we have the film aspect. This is where we're going to correct this squashed image. Let's just go to the side menu and select 16:9. And now you can see that the image is not squashed anymore. One thing to remember is that the render settings of your document get adjusted by the tracker based on the footage parameters you loaded. So if you look at the output, it's 1280 by 1080, which was the original resolution of the squished looking image. Let's adjust this either to 1920 by 1080 or 1280 by 720. Either will do. Now you can see that the image fills our viewport. Let's go and look at the next setting, frame start and frame stop. With these, we can define a portion of the shot we want to track. Although the full duration of the footage will still be visible in the viewport, only the selected range will be tracked. Let's open up the navigation settings. Since this is a two-dimensional image, navigating in three-dimensional space doesn't make any sense. When the motion tracker object is selected, your navigation shortcuts will actually zoom in and pan the two-dimensional image. And at the same time, you will see that these parameters here change, the scale and the two offsets. At any time, you can press full footage and the whole frame would be framed 100% in our viewport. The next two buttons, match width and match height, are used if your render aspect ratio and your footage aspect ratio are different. Then they will be active and you can use either one of them. In the visibility settings, you can make the footage darker so that overlaid interface elements are more visible, such as trackers and tracks. Show image shows and hides the footage in the viewport. Off and on. Keep in foreground forces the footage to be in front of everything else when the motion tracker object is selected in the object manager. Create background object. If I click on this, you will see that a background object is going to be created. A material is going to be created, and if you look in the material, you're going to have the footage loaded in the color channel, and if I click here, you will see that the animation has been enabled. Now, if I delete the motion tracker, you will see that the footage is here and it's visible in the viewport on the background object. Let me undo a couple of times and let me delete the background object, go to the motion tracker, and when this happens, all you have to do is untwirl and go and select the solved camera. This solved camera is the camera that's going to hold all our tracking data, and because it has this protection tag, that's why when the solved camera is active, we can't navigate in 3D space. I'm trying to navigate here and I cannot. One thing you need to remember is that when you have the motion tracker enabled and you have zoomed in and panned a bit in your 2D image, if then you create a background object, you will see that the material applied is going to have U offsets, V offsets, and it's going to have a scale as well. So make sure before you create the background object, let me delete these, make sure that the full footage is selected and then you create your background object. Lastly, there are a few lines of information here, what the footage name is, the dimensions, the total frames, and the memory usage, just for troubleshooting. Now you have an overview of the Footage tab attributes and how to use them. In the next video, we will continue with the 2D Tracking tab. In this video, I will show you how to do the simplest form of camera tracking using a mere few clicks. We are going to track the survey shot. So let's begin. Let's go to the Motion Tracker menu and add a Motion Tracker object. With the Motion Tracker object selected, let's go to the Footage tab and click here to load the footage. Let's find the blaster survey sequence and just double click on any of the frames. And you will see that the footage is loaded, but it's a bit squished because of the pixel aspect ratio. Let's correct that. Let's go to Film Aspect and select 16 by 9. And that is because I know it's 16 by 9. Number 2, let's change the resampling to 100%, so the image is fully sharp. Now let's fix our rendering output. Although it doesn't make a difference in this scene, we will do it anyway. So I'm going to make this 720, press enter, and now we have a full frame. As you remember from the previous videos, if you saw them, we will go to 2D tracking, start pressing these buttons and whatnot. But that's not what I'm going to do. I will go to the motion tracker menu and select the full solve. What the full solve does is it adds the automatic tracks, it does all the process of replacing the lost tracks, it follows these numbers here, and it tracks bidirectionally, and after it's done with a 2D track, it's actually going to give us a 3D camera solve. And I think it's already done. If you look down bottom left, you'll see it says running 3D solver, and we will see that prompt. And I think in just a few seconds I'm letting this run in real time so you get an idea of what kind of times you should expect with these settings. Changing these numbers will impact the time it takes for the solve. I think in a few seconds it's going to be done. Running 3D solver, maybe 5 seconds. Pre-optimizing, optimization, and deferred solve finished. When you see this, that means that your 3D solve is done. Now what we see here in our screen, these purple little dots, these are the 2D trackers. And if I scrub through, you will see those little squiggly lines. Those show us where the tracker came from 10 frames backwards and where the tracker is going 10 frames forwards. By watching these little shapes, you can estimate if a tracker is going off on its own tangent or not. If you see that there's uniform shape between these paths, these tracks, then you are safe to assume that the tracker is actually following the proper camera position. Whereas if one tracker has a very different shape to the ones around it, that means something is fishy. Other than this cryptic message, there's nothing else to indicate that the solve has happened. So what I'm going to do is click on this, and you will see that we have the solved camera, and you can see when I click on it a horizon, and we have this null that contains the auto features. If I untwirl this, you will see that the features, which are basically the nulls that are in the 3D positions represented by the 2D tracks, are listed, are sorted with the highest quality on top and the lowest quality on the bottom. And you can see that reflecting in their color. We'll see how to use them later on. Now you can obviously see if we go to the 4 views, and what I'm going to do is click here, press H to fit everything, click here H and click here H. This is a very clear view of what's going on. We are actually seeing the floor of the survey shot at a different angle. And that's a very natural thing that happens. The camera, the tracker, does not know if this is a floor, or if this is a wall, or if this is a ramp, because everything is virtual. We can tell from this view that this is the floor. And although at this particular moment we don't need to do anything else with a survey shot other than go to the solved camera and copy the focal length, which we are going to use to track the other shot, and this is one of the purposes of the survey shot, I am going to show you a little nifty trick. So I'm going to maximize this view, and I'm going to select the motion tracker, and what I'm going to do is zoom out and use my rotation tool to rotate the whole system, so that this is pretty much aligned to our floor. The next thing I'm going to do is get my move tool and move this so that this is close to our world 0. You can see that there's a vertical distribution, and if we correct the other rotation, this one, I can press R to rotate and rotate it this way and then move it slightly down. What I'd like you to pay attention to is this curve that happens. This curve indicates that the lens has some sort of distortion, but as I told you before, it happens at the edges mostly, whereas at the center of our image it seems to be quite okay. And that is why all the features around our frame seem to have a higher error threshold. Because of this distortion, the tracker found them erroneous, so to speak. Anyway, I'm going to wrap this up by doing an interesting thing. I'm going to take a cube, and I'm going to make sure the cube is sitting on the floor. I'm going to make the cube a bit smaller, bring it down so it's touching the floor, and align it over here and rotate it around. Because I know that these points indicate that there is a floor here, if I go to this view, rewind and press play, you will see that the camera is moving. If I select the camera, you can see the camera is moving. This is the path of the camera when the cameraman shot it. It has been calculated by the motion tracker. And here you see the full 3D reconstruction of our scene. And you know something? For a couple of clicks, it's not at all bad. In Cinema 4D Release 19, the manual tracking has been enhanced and trackers can now be set to see user-defined color channels, making manual tracking and object tracking more predictable. Now the easiest way to see them, if we go to the 2D tracking tab, and you can see we have automatic tracking, manual tracking, you'll see some changes down here, and if we go to the options, you will see some changes over here. Now let's take a look at the options first of all, so you get an idea. The footage display, this is the original, as you can see in the viewport. But what you can do, you can tell it to see the tracker view. And the first thing you realize is that suddenly the tracker view is black and white. Well, yes, actually, when you use manual tracks in your manual tracking, the image that the manual track sees, and let me deselect this by pressing Control, you can see that our image is colored. But if I go and zoom in here, when I create a new tracker, the tracker does not see a colored image. It sees a black and white image which represents the luminance of our color image. And the problem is that certain tracker colors cannot be distinguished from their background. Take this one for example. If you remember, if I deselect this, this is a red tracker over a brownish looking background. And we as humans can distinguish the difference of the color of the background and the foreground. But if I add a tracker here, the luminance between the background and the foreground, actually it's very similar. And that's why some of your manual trackers failed to solve properly. So what we have in this case is the ability for a tracker to actually see a particular color. And how do we do that? Well, when you have your tracker selected, all you have to do is untwirl the color channel, and what you will see is that now the color channel is set to our default luminance. I can change this. And remember, the particular tracker was red. So I can click here and select a red color. And immediately the three values over here that control the amount of red, green, and blue change. And now we have a very contrasty feature, which is our red feature. Let me deselect this and you will see that it's red. I'm going to select it again. What else we can do is change the values to create a higher contrast. So we can go from plus 200 to minus 200. And if you want this to happen automatically, instead of choosing a preset of red, you can choose a preset of enhanced red. This will give you a higher contrast. And now you can see that this particular tracker is much more visible than when it was in our R18. This was the R18 evaluation, and this is the R19 possibility. And this will give you much stabler tracks. Now, the second thing that's changed is this square over here. So this is our search pattern. But in cases just like this particular scene, maybe we have round features, just like these little ping pong balls. And in order to center this, it would be nice if this was not a square but a circle. So if you go to the pattern shape, you can change it to circle. This way, by clicking and dragging on that little orange dot, you can align your circle with your circular features. And although the search pattern doesn't change, that continues to be a square. At least the interface is circular, and it allows you to focus on circular markers. So these are the main interface changes. And if you go to the Options tab, you find some of these defaults. For example, the footage display, if it's going to be the tracker view, which is the black and white interpretation, or the original, which is what we used to see in R18, is up to you. As far as the tracker behavior, these are the default values that will be applied when we create a new tracker. So if your scene has more, let's say, green trackers, all you have to do is go to the options and set this to a number that promotes the green. So I would put this to 200 and put the other two colors to -200. Now that this is the default, every time I go to my manual tracking and add a new tracker, so right click, create new tracker here, if I switch my view to be the tracker view, you will see that we get extreme contrast of the green feature. So depending on the number of features and if they have a similar color, you can set your default so that default is set when you create a new tracker. If not, just select this and press Command and click to select them all, right click and reset to default to go to that default value, which is basically the luminance value that Cinema 4D used in prior versions. Now I want to make it very clear because I think the question is coming. Many people may wonder, why don't we use the same sort of color technique in the automatic tracking? And the reason is very simple. When we add automatic trackers, these automatic trackers are going to be added in areas that already have a high contrast. The reason this has been added only in the manual tracking is that in the manual tracking, we as humans perceive the difference between colors in a different way than the algorithm does. And that's why now we're allowed to change the colors so we have a clearer view of our features. Okay, so it doesn't make any sense for this particular thing to work in the automatic tracking. So there you have it. With these two little interface changes, the actual pattern shape from square to circle, and the color channel to be able to be customized, and not only the luminance channel of the RGB image, our manual tracking, hence much more stable results. One of the very helpful interface elements we have in our motion tracker arsenal is the motion tracker graph. Let's go and open it from the motion tracker menu, motion tracker graph view, and here it is. Now, mind you, you need to have a motion tracker object selected, and then you see this, but if you press H, so to zoom in, you can see all of the information for all the automatic tracks, all these little buggers here, for the duration of our animation. Okay, and what you see here, the way this is sorted, is based on which part of our shot a tracker is visible. So, you can go here in the beginning, and you will see that the particular tracker we're looking at over here is somewhere here in the back. Look at that. There you go. So as I scrub from 0, you can see it's nice and orange, and then it loses it. There you go. So you can presume from this that this little tracker here was only found during the automatic tracking process from frame 0 up to frame 12 or 13 or something like that. Now let's take a look at the colors for a moment. Let's bring this in view. You can see that we have all these different values of green. Now the brighter the green, the lower the error threshold, and you will see that we don't have much error. And the reason is, if we go to our motion tracker, we went to the 2D tracking, automatic tracking, and we have our error threshold. Now if I turn off the error threshold, this will allow us to see all those automatic tracks that have a very high error value as well. So this is what the color coding does and how it works in tandem with the filters. So let me turn this on, and let's take a look at a few of the other colors. The yellow is a keyframe. So wherever you see yellow, that means that a snapshot of the pattern was taken at this frame for this particular tracker. Let's see if we can find this one now. Where is this tracker? First of all, I'm going to do the following. I am going to put this down here, and number 2, I'm going to go to my footage and make sure we see the full footage. There you go. So you can see this tracker up here is represented over here, and it has a snapshot of this. And if the tracker's happy, then I'm happy. I have no problem. You can see various amounts of error. But let's see what happens on either side. If we go to the end of it, you can see we have this fuchsia, this magenta color, and it says, when I hover over it, error filter trim. This means that the values after this were trimmed because of our error threshold. That's as simple as it is. If I hover over this one, it says smart acceleration filter trim, and so forth. So this color code tells us the reason why there are no more calculated positions from this point onwards. It's either based on acceleration filter or based on the error filter and so forth. When there's nothing here, it just means that the tracker was lost. It wasn't filtered. It was that it couldn't find any more information on this frame. So let me do this. Let's see if we can find this little tracker. Let me close this for a second. I hate when big things are right in my face. That's why I have 2 monitors, but you can't do tutorials for 2 monitors. Full footage, and if we look around for a few seconds, we may be able to find that selected tracker, which is the one right over here. Okay, so it just vanished. There you go. It vanished. It went out of frame, and that's why there was no color code to tell us why this particular tracker vanished. Excellent. So these are very helpful tools. They allow you to see what's going on, and we will use it quite extensively when we do the manual tracking. Now let's go and see what other modes we have here. I'm going to press H to zoom everything, and when the vertical resolution is 1 pixel, it doesn't get smaller anymore. So there are trackers both on the bottom and above, but it can't become smaller than 1 pixel. So you will find that for scenes that have lots and lots and lots of tracks, you won't be able to see them all at the same time, unfortunately. Let's take a look at what's going to happen if I go to the motion tracker, 2D tracking, and change the error threshold. So I'm going to make it higher so we have fewer tracks. Oh, sorry, that's more tracks. So I'm going to put it very low. And you can see that we only see the tracks that have an error threshold value lower than 4%. Now the other trackers are not deleted, they're just hidden, and they don't participate in the calculation of the camera solve. And that's fantastic, because if we change our minds about something like the error threshold or the smart acceleration or whatever, we can always go and just move the filter, and we don't have to track again. Excellent. So this is a dope sheet, very helpful. But we can go here where we have the actual graph mode. If I click on this, you will see the same things, but as graphs. Interesting, huh? You don't see the dope sheet anymore. You can see the actual graphs, and this is the error value for the specific tracker. And you can modify the error threshold by moving this red line over here. So visually, you can use this. Let me press H, and actually what I'm going to do is dock it here. Press H so I have an overview of it. Then go to my footage and go to full footage. So I can see what's going on here, and I can say, okay, this tracker goes from zero error, because that's where the pattern was recorded. When the pattern gets recorded, the error is 0, because that pattern defines what everything else is going to be compared to. And I can either select them here, or I can go and select them here. But we're on this frame, and you can see that this line, which indicates the lifetime and the error of the particular tracker, is not on frame 0. So we have to move here in order to find it. And there it is. It's over here. And normally you'll see the errors grow as the tracker evolves. That's why we add more and more and more trackers on new features, so that the overall error threshold is quite low. Now, the lower the error threshold, the fewer trackers we're going to have. So sometimes you may assume that we can make this extremely small and we're going to have a perfect solve. But then you're going to have other problems, like, for example, a lack of enough automatic trackers to average out any other errors. But overall, we can use the motion tracker graph view to fine-tune our track and make our solve better. Finally, to close this off, I would like to show you that we can see the actual 2D tracking speed or the 2D tracking acceleration. These are a couple of things that have to do with the other two filters. So again, let me right-click and undock this. Closing off this video, you have the ability to filter your trackers based on any of these three things. I personally work with the error, and in my view, for these kind of shots, 15% is good enough. And what that percent means, I'm not really sure, but it works quite well with 15%. And I mostly work in this view when I'm doing my manual tracking, and we'll see this a bit later. We're going to be using the motion tracker graph view quite a lot. After a fair amount of manual labor, I have managed to track all the manual trackers that belong to the object. Let me scrub so it goes a bit faster. There you go. You can see them moving over their features. Fantastic. So how do we solve for this object? Well, let me show you. Go to the motion tracker and go to the 2D tracking, manual tracking, and you will see all the user tracks. So make sure they're selected. They were, but I'm showing you, you can do this by clicking and then shift clicking over here, and we have all of them selected. The next thing we need to do is go to the motion tracker menu and add an object tracker to the scene. And let's call this weapon. You don't have to, but why not? And with the weapon selected, go to trackers, and because we have all these trackers selected, we can see them in the viewport. Click on assign selected, and then all these manual tracks are going to be assigned to the object tracker called weapon. Now if I go to the motion tracker, you can see that they have the prefix weapon, and that's because in the options I turned on this. If I turn it off, you won't be able to see it. If I turn it on, currently we have only one object tracker, so we won't get confused. If you have more than one, it's good to know which ones belong where. Fantastic. So don't forget, in our motion tracker we had this on, lock solve data, before we started tracking these manual tracks. And now all we have to do is go to Weapon, Reconstruction, and press this button. It's going to take a couple of hours. No, I'm joking. It's just going to take 3 seconds, and it's already done. That's it. That was it. Now look at this. You can see that the axis of the weapon is moving because now we have keyframes. These are the calculated keyframes. Let's take a look at something before we do anything else. You can't see the object here, can you? Now let me zoom out and zoom out and zoom out. The object is somewhere down here. You can see it moving. Now that's odd. Well, actually it's not odd. How can the tracker know that our object is of a certain size? This can be a cannon that's 200 miles down the road, or this can be a very small weapon that someone's holding in their fingers. So we need to actually calibrate it for size. Let's go and do that. Here we are in our 3D viewport, and we can go and add some of these calibration tags. So right click, motion tracker tags, and what I'm going to do is assign a vector constraint. And what I'm going to do here is scrub to a frame where I can see, there you go, I can see these two, this one and this one. And I think that this one and this one are about 15 centimeters away. So I'm going to grab this, put it here, click here. You have to click first and then drag it, and it has a snapping. If I release here, it's going to snap. What I'm going to do, I'm going to forget about the axes for now, and I'm going to say the length is known, and it's 15 centimeters. When I say OK, you won't see anything really happening here, but when I go to my top view now, let me deselect this so I can go in. Now you can see that the weapon is pretty much where we expect it to be, because we've calibrated the camera approximately, and now we're calibrating the weapon approximately, and that's good enough to see a, so to speak, realistic view of what's going on. Now of course I can tell this that it's on the z-axis as well, so this will allow me to calibrate so that I can go and assign some sort of object. Well, let's go and see how that works. So let's go to the 3D view, and what can I do? I want to make it a bit fancy here. I am going to create some text, and the text is going to say weapon, and make it a child of the weapon object, and make sure all the coordinates are zeroed out. Good, and you can see that it's moving. There you go, fantastic. I'm going to do certain adjustments here. For example, I'm going to add an extrude object, so it's nice and 3D. Select this and scale it down. Scale it, scale it, scale it. Now let's see again. You can see it's moving with this lady, but I'm going to rotate it so it's 90 degrees that away. And then I'm going to move it that way and then bring it down. And you can see now that she's carrying a weapon. Look at that. Now because we have all these nulls here, you can always go to auto features and make them invisible. Look at that. Isn't that interesting? Now if you want to fine-tune it, there are a couple of tricks you can do. So I'm going to select this null here, go to the top view, and you can see that the word is sort of aligned to this null, and that's all fine. Let me go to another view and say, right, this is the back end of it. I need to find that little null. There you go. Where is that null? Oh, it's over there. So our orientation is actually quite good. But basically you eyeball it by going to one of your top views, selecting your nulls and adjusting the model to fit your 3D object. So that is how we solve and how we calibrate our 3D object. And if you actually create a proper model like I did for the final view, you can place it here and it looks absolutely fantastic. I'm going to just copy and paste it in here. So I have my weapon here. I modeled this. Fantastic, isn't it? Anyway, I'm going to copy it and go to my other scene and paste it. I'm going to make it a child of the weapon. Let me get rid of the text. And I need to make sure that the coordinates are 0, 0, 0 and 0, 0, 0. And let's see how this looks. Not bad. I think I need to adjust its position ever so slightly because this is in the front, so I'm going to move it that way and a bit further down. Let's see what this does. There you go, and I need to rotate it ever so slightly, and again I need to follow the rule I set earlier. You can see that it's ever so slightly off because I need the tip to be here, but I need the back to be over here. So I'm using my nulls to place it properly. Let's go and see in another view if we can do some corrections over here. Let's see, and let's take a look in our 3D view if we did something interesting. And yes, we did. The good lady is holding a weapon, and I can now make these invisible, rewind, press play, and enjoy my masterpiece. In this video, we will track our main shot's camera motion assisted by the focal length we calculated in the survey shot in the previous video. So let's double click here, copy this value by pressing Command C or Control C on the PC, and let's open a new scene and create a motion tracker object. Go to the footage tab and click here to load our footage. Blast the walk, double click on any of the frames, and the footage will be loaded. Let's go to resample, make it 100%, so we have the full quality of our footage. Let's go to custom, change it to 16:9, and now let's correct the render output to 16:9, and everything is fantastic. Now before we start, I need to go to reconstruction. I need to tell the focal length that it's known and constant, and I'm going to paste, so Command V or Control V, and all I have to do is go motion tracker and full solve. You can see that it's preloading the footage in RAM. Now it's processing the frames, which means it's actually conducting the 2D track. And now it's running the 3D solver on the 2D tracks. And with the help of some time traveling, the solve has finished. Let's see what it looks like in our 3D views. Press H, click here, press H, click here, press H. Now you can see all these red trackers, and these are the ones in the distance. And because here the resolution, so to speak, is much less, the detail is much less, that's why they have a high error, and that's why they are red. You can see that the green ones are concentrated close to the camera. Now let's go to this view. Let's zoom in. And you would assume that I'm going to start rotating the motion tracker like I did before. But I'm not going to do that. What I am going to do is use the proper way to calibrate my scene for orientation and scale. So, I'm going to maximize this view, select the motion tracker, and do the following. I'm going to go to the motion tracker menu, go to constraints, and use a planar constraint. This is going to ask me for 3 points, and these 3 points need to lie on a plane that I know defines an axis. So the floor, I'm going to click here, then I'm going to click here, and then I'm going to click here. And in the attributes, I'm going to say that this defines the y-axis. So go here and say y. Let's go to our 3D view, and now you can see that all these points are lying on the floor. Here in the planar constraint tags attributes, we can see the 3 nulls that define this plane, and they're all green, which means that they're relatively good. But at any point I can change them. I can either go and select one of these corners and pull it and take it to another point, or I can just go here and select another null. But I'm going to leave it as is for now. Something I failed to show in the original recording of this video is the following. When you select one of these constraint tags, you will see that we have this selection. I can use more than 3 nulls. So how do we do this? Well, you lock this palette so it doesn't close, and then you go to your auto features. Actually, you don't have to go. You just go and select some of your auto features. So I'm going to deselect my tag, go to my selection tool, and select features here which I believe lie on the same plane. So I think these are enough. Then the next thing you need to do is go and find any one of them and drag them in the locked selection. So what this is going to do, it's going to take all the nulls you've placed in this box and average them out and find the plane. The next thing I'm going to do is find some 2 points which I can estimate very roughly the distance, and this will allow me to calibrate my scene for scale, because at this point the tracker doesn't know if these 2 points are 1 mile apart or 1 foot apart. So doing the same thing, motion tracker, constraints, I'm going to create a vector constraint, and I'm going to click on this one and this one. Now I can always say that this is on the z-axis, so it's going to orient my scene so this is facing towards the z. If I go here, I can navigate, and you can see this little blue line indicates a z-axis. Now let's think about this. What do you think is the distance between these things? I would say, judging from this here, it's about 1.5 feet. I'm going to say 40 centimeters. So with the tag selected in the attributes, the length now is unknown. I'm going to say known, and I'm going to put 40 centimeters. And now my scene is calibrated for scale as well. There you go. And there you go. You can see there's a very slight incline, but that is probably because these points are not totally aligned. What I can do is go here, use my move tool, click on this and drag it right over another one. And you can see that the incline changes. It's actually worse, so I'm going to drag it and put it there. And I'm going to try and find a point that makes this look a bit more level. Maybe the problem is not that one, maybe the problem is this one. So click and then click and drag. Ah, that looks better. Click and drag. No. Click and drag. Excellent, that looks much better, and I'm going to leave it as it is. One thing you need to be aware of is if I try to navigate at this point using my navigation key, so I'm going to press 1 and click to navigate, you can see that the point moves. Undo. When a constraint tag is selected, then we cannot navigate. I have to deselect it and then navigate using my keys. So what I was trying to say was that currently the camera is at the 0, 0, 0 point. I don't want the camera to be at the 0, 0, 0 point. I want the floor to be level with the 0. So what I'm going to do is add a third type of constraint. Motion tracker, constraint, and I'm going to use a position constraint. I'm going to click on this point, and you can see it defaults to 0, 0, 0 for X, Y, Z. And now my scene, I'm going to deselect this so I can navigate, is calibrated perfectly. Let's go and test it with some geometry. I'm going to make a cube which is 50 centimeters. On each axis, I'm going to raise it 25 centimeters. And I'm going to use my move tool to move it somewhere over here. And now I'm going to deselect everything, rewind, press play, and you can see that the cube is nicely stuck to the ground. We have successfully tracked and calibrated our scene. The next step is to go and track the object, the prop that this good lady is holding. Before we start tracking the object, there are a few things I would like to show you in regards to the workflow and tools involved, so you know what's available and how these tools work. I'll show you these using the previously camera tracked shot. So let me simplify this. I'm going to get rid of these two cubes, and I'm going to get rid of my constraint tags for no other reason other than I don't want to have them in my viewport when I'm working, so they won't make a difference in this case, so I'm going to delete them. The other thing I would like to do is bring up my motion tracker graph view and dock it over here so I have it in front of me. Now I've got my motion tracker selected. I'm going to press H, and you can see all these auto tracks. I don't want to have these auto tracks. I'm going to go to the select, and I'm going to select all auto tracks. Excellent, and then I'm going to go and hide the selected. So the auto tracks are hidden. If I press H, there's nothing here. And from now on, any manual tracks I will create. So I'm going to click here. I'm going to move this up over here so I have a bit of working space. And as you can see in my 2D tracking, manual tracking, I don't have any tracks. So let's create a tracker. I'm just going to right click, and what happens is if a motion tracker object or a object tracker object is selected in the object manager, then the right click actually gives us the tools specific to this. So you just right click anywhere and you say create user track here. Now someone would ask me, of course, where is the here? What does here pertain to? So let me delete this. When it's orange, it means it's selected, and if I press backspace, I can delete it, or if I select delete user tracks, and I can multi-select either in my viewport or over here. Let me quickly do that. So right click, create user tracks here, right click, user tracks here, right click, user tracks here, and you can see that the unselected manual tracks are X's, and the selected ones are these orange yellow squares, which give us the pattern square and the search area square. And if I go here, you can see which one is selected. It's highlighted, and I can always use my shift key to select them all, and I can delete them all, or I can select them here and delete them. But anyway, that's how it works. Okay, what is here? I'm going to place my mouse pointer over this black feature, and I'm going to right click and say create user track here, and the here is where I originally had my mouse when I pressed the right click. So this is my manual tracker, and I can adjust the pattern and the search area and so forth. And I have a tracker, and basically I've created a tracker, and at the same time I've created a tracker keyframe, a key. Now if I want to see it here, I just press H and here it is, and now it's zoomed in quite a bit. You can see the frame numbers up here, and I'm going to make it slightly smaller. There you go. So on frame 151, which is here, we have a key. What do we do with this? Well, let's go and adjust our interface the way I prefer to work, although you can always go and select your motion tracker layout. I like to just rip this off and bring it over here and work with what I have. One thing I'd like you to notice is that the auto update tracks is by default on, and I'll show you what it does. The first thing you need to do after you've created a tracker and you've placed it, that doesn't need to happen in one step. Let me go and delete this one more time. If I want to place a tracker here, I can always create it here, or I can create it anywhere, and then I can grab it from the center and move it here. And it's exactly the same thing. It's the same keyframe and the same pattern. So what do we do after this? Well, if we don't do anything and we start scrubbing, you will see automatically that our tracker is red. And that means there is no tracking information associated to the specific frame for the particular tracker. Any trackers that are red for any region of our shot are just going to be ignored when we do the solve. Excellent. So I'm going to go here, and I'm going to press one of these three buttons: track bidirectional, track forward, or track backward. Now what you need to do, for several reasons, is only work with track bidirectional. I'm going to give you a very simple explanation. The first time you use one of these three buttons, when you create a new tracker, then every other time you want to add a key and track forwards or backwards, this will not happen. It will only track in the direction you originally designated. So if your original tracking is forward, then from then on, all keys for the specific track will only track forwards, regardless of if you press the backwards button or the bidirectional button. This is a slight limitation which Maxon is working on, but for now, forget the forwards and the backwards. We always use bidirectional. Having said that, we're on our key. Here it is. Let's press track bidirectional, and you will see on the bottom left that it's processing, it's loading the images, and it will track the specific feature for as long as it can. The lines that show the trajectory of the specific track on our footage are 10 frames in advance and 10 frames trailing. And as we move, you will see that the tracker is following the feature, and when it reaches a point where you can see here that a bit of red enters our pattern, that means that the pattern has changed. At least that's what the tracker believes. And you know something, that's what happened. If you look here, you will see that it stopped because it can't find the pattern from this point onwards. And if we go to the left, I don't like the fact that this is leaving my screen. It's irritating me. That's why the good developers at Maxon allow us to have the lock view on tracks. If I click on this when my tracker is selected, this is what happens. The footage moves behind, and it's amazing because you can troubleshoot what's going on. You can see how much the tracker is moving in relation to the feature. So let me make this a bit smaller, and we can see the full range of the automatic tracking. So as I've said previously, when we do manual, also known as supervised tracking, we manually set our features and our trackers, but then the actual scanning of the footage to find the trajectory, the position of that feature in our footage is done automatically. That's why it's supervised, basically. And we go up to this point. So excellent. Now it's leaving the frame, and there's nothing else we can do about this. So let's go in the other direction. You can see that it lost it. What can we do in this case? Well, there are a couple of things we can do. We can set a new keyframe, and without touching anything else, if I right click and say insert key at track position, it's just going to take a new snapshot of the pattern in this particular frame and use that to see if it can track in both ways. So insert key and track position. I'm not going to touch anything. You saw the calculation took place for about a second and a half, and the reason is that the auto update tracks was selected, which means that every time we add a keyframe or we modify a keyframe, the tracker will try and track automatically without us telling it. And you can see that it actually did quite a good job up to a certain point. Now look at this. Look at this jump. This doesn't make sense. Although this is perceived as a good calculation, a good track, it's obviously not. And these are the parts of your tracking process where you actually need to do the supervision. So move as much as you can so that the tracker is properly locked on the feature, and then just insert a key at track position, and it's going to recalculate. Let's see what happens in the following frames. And it's done quite a good job. Again, let's go to the last frame, which we consider to be good. Insert key at track position, and so forth. And this is the method we will use to track. And you can see that it took a bit of time, because after this frame, for some reason, the tracker, although it does jump, it thinks that it's tracking the feature. This is a type of supervision you need to do. Now, this is not the best feature to select, and in this case I'm going to delete everything, because we are actually going to work on the features on our object. In the following video, we will track one of these features from beginning to end using everything we've learned up to this point. In this video, we will continue our exploration on the tracking of 2D features for an object track. In this case, I'm going to choose a feature which doesn't have many problems, so it represents a best case scenario, as I call it. And in our footage, you can see we have our previous tracker already tracked, our previous feature to be precise, and I'm going to focus on this one here. So let me zoom in. What you will see is that it never goes in front or behind another feature, and that will make the shape relatively constant throughout, and that's fantastic. So let's go right here in the middle, and what I'm going to do now is press Command and left click to create a tracker and make it slightly bigger, and let's make it flush with the circumference. I'm going to zoom in and use my Command arrows or Control arrows on the PC to nudge this into place. And I think this is a very good feature now. So what I'm going to do is rip this to the side. At the same time, I'm going to either go here and select the graph view from here, or just click on this, and I'm going to dock it over here, and I'm going to make it slightly smaller by pressing 2 on my keyboard and zooming out. Fantastic. What I'm going to do now is make sure the auto update tracks is on, and you can see that automatically it was bidirectionally tracked. So let's go and see how it looks. Now you can see that the tracker is moving, although the lock view on tracks seems to be activated. This is an interface glitch. Whenever you change tracker, you have to click on it again to activate it. So now it's going to work. So we go forwards, and you can see that only at this point it kind of jumps away, and that is probably because some sort of change of contrast. But anyway, I'm going to go to the last keyframe I consider good enough. This one, for example, maybe a few more. There you go. And although it seems to have moved ever so slightly, I think it's good enough for what we want to do. So go here, right click and say insert key at track position, and because the auto update tracks is active, you will see that it will track a bit more by itself, and then go here, right click, insert key at track position. You can watch the progress of the tracking over here. I'm going to move forward, and you can see that we have a bit of a problem over here. So what I'm going to do is do a bit of manual tracking on this end, and I'm going to move this over here, and you will see that it didn't track backwards, although it should be bidirectional, and that is because the front tracking from this keyframe takes precedent. So unfortunately, you will see that we get a significant jump. So I'm going to divide and conquer. I'm going to go somewhere here and move this right to the center, and some sort of calculation is going to occur over there, and then go right here in the middle, move this, and it will auto track. So I've conquered these ones, and I'm going to go right here in the middle and do this one here. Excellent. And then I think I'm just going to manually correct this. So again, by using my 1 frame forwards, 1 frame backwards, my G and F keys on the keyboard, I'm going to make sure that the tracker is nicely placed. You can see we have a huge jump over here, so command and nudge to the right. You can see it takes a bit of time because every time it's processing a few frames. Luckily they're not many, so it takes a split second. So let's go and move this. There you go. And again, let's move this to the right, and let's do this and a bit more. That seems a bit better, and actually I can do it with my mouse. A bit more. Maybe I should go in the middle here and bring this over here, and then over here you can see there's a jump. I'm going to move it this way, and here a bit more. There's a bit of a jump, but that's not too bad. Excellent. If you want to be a bit more precise, you can always go and correct these. You can see there's a slight error value here, so we can divide and conquer here as well, and so forth. So, you can do it or not. At the end, if you have trackers of this quality, but quite a few of them, the actual error will average out, so you won't have such a problem. So let me move backwards now, see what happens here. There you go, we lose it at this point. Let's go over here and set a key at track position. You can see that it slips ever so slightly at this position over here. We see this jump. I'm going to make sure that this is slightly better centered. There you go. A very minor jump, but that's good enough. And let's see what happens in the previous frames. Not bad. Very minor little glitch here because we get the other feature jumping in. So I can use my nudge on my keyboard. I'm going to set a key in track position over here. And let's see. Good. That sort of corrected it, and all the way back here. Excellent. So let's pull out. Let's rewind and press play. And you will see that overall it may not be 100% accurate, but it's stable enough, and it's going to contribute quite well in our solution. Oh, I just saw a jump. There you go. That's a big jump. That is something I do not like. So I think this is a good enough frame to go and correct this. And let's move here and try and create some sort of manual tracking for this region. So we're here. There you go. That's where the jump begins. So I can do my manual tweaking. And there you go. A bit more of a jump. You can see that happens when the background changes significantly. And I'm going backwards and forwards, 1 frame backwards and 1 frame forwards. And you can see there's one more jump we need to take care of here. There you go, just to create a more smooth transition. And I think that now this is good enough. Let's see. Not bad. Not bad. Nice. Nice and smooth. Good. A bit of slipping, but that's going to be taken care of by the average of the errors. So this is what it takes, approximately 5 minutes, maybe less. And if you want to add a few minutes just to create a few more manual tracks to refine this. And this represents a fairly easy track. Now, one thing before I close off this video, there's a very important thing that has to do with the colorization. So we've been tracking white trackers on dark backgrounds. Our motion tracker uses the luminance value. The problem with that is that certain pure colors like green and red, when they're over grayish areas, the contrast is not that good. So although this green color seems to be just jumping out compared to the very dull gray background, this won't be a very easy tracker to track because the contrast of the luminance of the green color and the luminance of the background are quite similar. Let's see this frame in Photoshop so I show you exactly what I mean. So here's the first frame, and let's zoom in here and let me change this to a grayscale image. And you can see that there's not a lot of contrast if you compare these two and these two. Especially this one. I think this was the red one. Yes, the red one in particular, because the background is reddish gray. And let me go back to my grayscale. You can see that here the contrast is not that good. So when you're shooting your scene, make sure that there's a good luminance contrast between your features and any background. Or there's another method you can use. You can take your footage and you can process it through Photoshop or After Effects or Premiere or any other program that you can do some color corrections to a sequence of images or a movie, and make sure that you achieve the maximum contrast you can, and that will give you a very good solve despite the fact that it's on a black and white image. Those are some of the techniques that you may use, but it's good to know if sometimes you're wondering why a certain feature cannot be followed precisely by the auto tracking process. That is the reason, because our tracker currently only uses the luminance values. Let's take a look at some of the motion tracker's idiosyncrasies you need to be aware of to save you from unwanted surprises. Some of the following have already been covered in other videos, but it's good to have a centralized repository of annoying things, as I like to call it. I'll begin with something quite important. So here we have a final solved scene for the camera and the object. And you can see we have our user features and our auto features and everything else we need. First of all, I'm going to go to the motion tracker and make sure that the reconstruction lock solved data is on, and in the object tracker locked solved data is on. And you can see we have the user features, and when we select either of these we can actually see the automatic tracks or the manual tracks. Now what I'm going to do is go to the motion tracker footage and change the resampling. So from 50 I'm going to make it 56.25, and you can see that although the actual features, the nulls, are retained because these are physical objects, all the trackers, manual and automatic, have disappeared. Any change you do that has to do with the footage, regardless of if you are reloading the same footage again, this will force the tracker to delete all the automatic and manual trackers. And in the case where you don't have this or this enabled, doing the same thing will actually get rid of the features as well, which means you need to do your tracking again. Anyway, you can always undo, but keep that in mind. Let's continue with the luminance problem, as I call it. And this is that our tracker tracks the luminance value. So in order to show this, I'm going to add a hue saturation, and I'm going to take the saturation all the way down. So basically, this is what our tracker sees when it's trying to track the features. And as you can see, although the white ones have a quite good contrast with their background, the green ones and the red ones don't. So you need to be aware of this if you start wondering, why aren't my red trackers tracking nicely against the grey backgrounds and so forth. So it may be essential, depending on the color of your footage and the choices you've made to shoot your footage, or if the footage was given to you, you don't make that choice. You may need to go and change certain colors. So you can add some contrast brightness or whatnot just to enhance the contrast between the features and the background. Now, in some cases, you may choose to go and select a particular channel to work with. So if I get rid of this, delete, and I deleted the wrong thing, but that's not a problem. I'm going to go to my channels, and sometimes you can see that one of the three channels contains good information. So the red channel has good information for everything, including the red, and the green has very good information except for the red. You can go to your compositing program and create one composite black and white image that has these red features overlaid as white and the green ones and so forth, so that they all look somewhat like this. So it's up to you, but knowing that this is the way it works will allow you to make better decisions. So we have this particular manual track, and you can see in the graph view that we have some areas with high error, but that doesn't mean it's not a good track, and that's because I've actually placed most of these by hand. And you can see that the pattern size is a bit oversized. I did this on purpose. This is something you need to be aware of. If you have already tracked a tracker with manual keyframes and automatic parts, what will happen if you change either the pattern size or the search size? If I release this, take a look, it's processing. It's not only processing the frames on each side of this particular keyframe, it's actually going to process the whole of your track. So there's a good chance that certain areas which were good up to a certain point now are not going to be good. And there you go. The rule is that because there is no way, let me undo here, to lock down the actual 2D track, unfortunately, if you change either the search size or the pattern size, then the whole tracking for that particular feature will be recalculated based on this. So make a point on choosing your pattern size and your search size from the beginning. Otherwise, you will have to go back and see what has changed and go and fix it. The actual manual keyframes don't change. This only applies to any of the frames that have been calculated based on a pattern and a search area. In this scene, we have all our manual tracks visible in our tracker graph view, and you can see that the way it's sorted is from where the feature starts and where it ends. So you can see that this one that starts from a later time, it actually is placed up on top. And this is so that we can have a nice spatial arrangement of our features. Now with manual trackers, this shouldn't be a case, but unfortunately it is. And this is what can happen sometimes. Let's take this particular feature here, and let's go to frame 20. And, just add a keyframe. Automatically you saw it switch from up there down to here. So sometimes you may be zoomed in. So let me undo, and let me zoom in here. And I'm focusing on this particular one, and I just do this and I move it. There you go. And you can see that it will change position, and very frequently it may disappear from your view. So be careful with that, because it will jump depending on where it starts and where it ends. You may be surprised sometimes if it disappears from your graph view. Just make sure you press H or something like that, and make sure you can see where this brown orangey line is, and that means it's your selected tracker. Another thing that bugs me sometimes about the lock view on tracks is that if I have this tracker selected, and you can see it's locked properly, I can move it around and it stays locked, and that's fantastic. If I move to another tracker, just click here and scrub, you will see that it stays locked on the previous one. So this is a bit deceiving sometimes because you can see the lock is activated and you can see a tracker selected. You would assume that it's activated because of this. Anyway, the solution is quite simple. You just click on this one more time. If you click a second time, it will just deactivate, and yeah, then just click one more time and it's active. So every time you change tracker, just click on this once and it will lock the specific tracker. Deleting trackers sometimes may cause some odd things. So for example, if I go here and select a tracker and press backspace, then it deletes that particular tracker. So everything is fantastic. Okay, let me undo. Now, if I select this, which means I'm putting my focus in the object manager, then select a tracker over here, and then press backspace, it will delete everything. And when I undo, it will actually take me to the motion tracker, and I need to activate the camera to go back where I was. So the safest way to do it is, if you're generally selecting things in a viewport, you can use your backspace to delete them. But if not, and you want to activate and select these, just go and use the delete user tracks over here, so you have less headaches. It's very important to remember that when you create a new user track and you adjust whatever you adjust, whatever of these three buttons you press, that is going to be the direction that is going to track, regardless of which one of the buttons you press afterwards. So if this is off and I press track forwards, it will track forwards. And let's bring our motion tracker view, dock it here, and let's go and select this one. You can see it up here. It only tracked forwards. Excellent. So now if I go here and I say, okay, I want to go here and I want to track backwards, you can see that it doesn't track backwards. If I say insert gear track position just to reset it and track forwards, you will see that it will track forwards. So always remember, my proposal is always use bidirectional, and for the majority of cases, auto update tracks is what you need to have selected. I've prepared a very specific scene here. Now, although I did track this object successfully, you can see the particular object has keyframes from the beginning to the end, and this is what I used to create my fantastic animation. What I've done, I've changed the way the manual tracks are calculated, and I've deleted the frames here in the beginning. I only have 3 manual keyframes here and 4 here. So I know by definition that from this point onwards and from this point and before, there is no way for the object tracker to calculate the position of the object. So let's see what happens if I tell it to run 3D solver for object in this case. So it's going to run the solver, and what you will see if you look down here is that it only created keyframes for the range where it feels that it has some information. We already know that we can go to the motion tracker footage and click this button to create a background object. And this is going to create a background object, and it's going to create a material where the image sequence is loaded in the color channel and is set to animation, and here are a number of frames. Now there's a bit of a limitation here. If for any reason your footage doesn't start from 0000 and it starts from 1 or 2 or something like that, then creating the background object will cause some problems with the animation. So my advice, because I don't know why it happens and it's a bit too complicated anyway to understand this, my advice is that if you're going to use the create background object, just make sure that your footage, if it's an image sequence, starts from 00. If it's a movie, that doesn't make a difference because the frames are allocated automatically. But if you have an image sequence, make sure it starts from 00. There are tools for both Apple's and Windows machines where you can renumber your sequences. And I think it's just a 2-minute thing you need to do to make sure that everything works perfectly. Another thing I need to remind you of is, let me delete this background object and delete this. If you have the motion tracker selected and you have zoomed, let's say over here, and you say create background object, the background object will be created fine here, but the texture tag applied to the background will have all these offsets. So if I delete all these and render, you will see that I get a render which is similar to where I had zoomed in. And of course, this is not going to match your 3D view. So make sure before you create your background object that your motion tracker is set in full footage, and then create your background object. It's time to start tracking our object. In order to do that, I'm going to select two different features on my object. Mind you, we're using the scene that has already been solved for the camera. It hasn't been calibrated, but it doesn't make a difference. The process I'm going to show you applies to any stage of your tracking, whether you've done the camera solve or not. It's only about tracking 2D features. Now, I'm going to make a couple of videos. This one is going to show you how to track from end to end a feature which is quite challenging, and this is going to involve quite a lot of manual labor. The next video is going to show a feature that is much easier to track. So let's begin with a hard one, and let's go and identify it. So let's scrub here and see what we can find. Let's see, I'm going to find one that has some sort of overlapping. There you go. So what I'm going to do, I'm going to zoom into this one. So this is nice and bright, but it actually goes in front of this one over here. And that's going to alter the pattern. So it's going to present some challenges, which we will have to go and correct manually. So let's go to a nice part of our footage, somewhere around here. And what I'm going to do is right click and create user track, center it, and make it flush. I think that's good enough. And so that we can work easier, I'm going to open up the graph view, and I'm going to drag this and dock it over here. And what I want to do is go and select all auto tracks, and then I'm going to hide selected. So now if I press H, I can only see my manual tracks, and this is my first keyframe. Excellent. So I've created this. I'm going to rip out my motion tracker menu, put it here on the left. Keep auto update tracks on for now. We may turn it off later on, and track bidirectionally and see what happens. It did its calculation. You can see it's moving around. Lock view on tracks to keep it fixed. And let's go and find. Let's see what's going on here. And there's where we lose it. Now here's an odd thing. There's this tracker, and this may happen to you. Just know that it's a limitation. Sometimes, it's very rare, but it happens, an automatic tracker just appears out of nowhere. So just select it and just press backspace and delete it. Okay? Apparently, this is not a random auto tracker. It's a tracker that was deactivated by the Smart Acceleration filter. By adding the manual tracker, we altered the Smart Acceleration's decision, and it activated it again. Since originally it was not valid though, by deleting it you're doing no harm. So that's why it's good to work with a clear view of what you're working on. That is just a minor limitation. Anyway, back to this. So if we move forward, you can see that the color changes, which means we have a higher error. And here you can see now, look at the top of the little sphere, it's actually starting to pop. That means that we're losing the center of our sphere. Okay, so what I'm going to do is go around here and right click and insert key at track position. It's going to add a keyframe here and take a snapshot of this. So now we know that at least this range is pretty much locked. So let's move a bit more. You can see we're getting this slipping here. It recovers somewhere here. It's pretty much centered. Let's right click, insert key at track position here. So we have a bit of correction to do here if we choose to do so. I have to tell you that it's not that bad, so we can leave it as it is. But here's where the problem starts. When the other feature enters the pattern area, that's where it starts moving around. What are we going to do? Well, first of all, it totally loses it after this point. I'm going to go and start setting keyframes at the first frame where I see some significant difference. And I'm going to use my keyboard shortcuts, G to go a frame forwards and F to go a frame backwards. So I'm going to go between front and back quite a few times because this allows me to see the difference between the two frames. And as you can see, from here to here, there's a slight motion of the feature down. You can see it goes down and up, down and up. The general rule of thumb is that when you're doing frame by frame manual tracking, you need to move your tracker in the same direction where the feature is moving. So you can see the feature is going down. So press Command and down arrow on your keyboard to make it go down, and then check it again. Now you can see that it's much steadier. Let's go to the next frame. It goes down. Press Command and down arrow. Sometimes you may need to press your down arrow a few times, and you can see still it seems to be going a bit downwards. So that's good. It goes a bit to the right, doesn't it? So Command right and back, front. Sometimes by mistake I go front instead of going back, but yeah, good. I'm just comparing the two. Then let's go to the next frame. Oh, this is down. I did 2 Command down arrow clicks. I can't keep repeating Command down arrow, Command up arrow, because then this video is going to end up being 2 hours. So when the tracker is moving, you should assume that I'm actually pressing Command or Control on the PC and the arrow keys on my keyboard, which is the equivalent of nudging up and down and so forth. So I have my fingers placed on F and G, and depending on where the feature is going, I'm pressing the arrows. And every time I press the arrow, because the auto update tracks is on, you will see just a fraction of a second where it does some sort of calculation. One thing you need to know is that if you are somewhere where a key doesn't exist and it's just a calculated position of your tracker, if you go and modify the position of the tracker, then a key will automatically be set over there, just like if you pressed insert key at track position and then did the motion. So just remember that. Back, front, and I'm talking about the frame. Back, front, that looks pretty good, maybe a bit to the right. Back, front, perfect. Front, it goes down. 1, 2. Back, front, down. Back, front, down. Back, front, a bit to the right. Back, front, perfect. Front, down. Back, front, front, back, front, perfect. Maybe a bit to the right. Whoops, actually that was wrong. There you go. Good. And as you can see now, funny enough, it has tracked a few frames which are not that bad, but here it starts moving again. There you go. That's where more movement appears. All I have to do is insert a keyframe, and you can see that now, if you look here on the graph view, you can see that we have 5 frames that are calculated. So we saved ourselves 5 manual frames. And let's move on. Let's see what goes on after this. Actually, that's not very bad. I think it's nearly perfect. That's fantastic. So that's it. That's where the footage ends. Excellent. So we've tracked this that way. You can see that there's generally a little bit of slippage, but we can get away with this amount of slippage. If you are such a perfectionist and you want this to be an absolutely perfect track for the sake of it, then you may need to go and do a lot of manual keyframes. But anyway, let's go into the other direction now. So backwards and see what happens here. And we have pretty much the same situation. So I go to the last frame, which is acceptable, insert key in track position, and you can see that quite a bit of calculation occurred. Here we have a bit of a problem. I'm going to go here where it's good and insert a key, and then I'm going to fiddle around with these intermediate ones. And what I'm going to do is just work backwards using my F key. So backwards, there's a slight motion up, and you can see here it totally loses it. I'm pressing Command and arrow key a few times. I don't have to, I can always go here and move it, but I don't like to remove my hand from my keyboard to my mouse. That is something that I find extremely irritating. So you bring it close enough and then you just nudge it. Again, the golden rule is when you move to another frame and you see the feature moving in a certain direction, so now it's going a bit down and a bit to the left, that's where you need to push your tracker. Here we have a huge difference, so I'm going to place this here as accurately as possible. So front, back, and then move the tracker a bit down. Perfect. Next one here. Excellent. And go back, front, so it goes to the left and goes down. Back, front, a bit to the left. Back, front, a bit to the left. Back, front. Perfect. Next one. Right, 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 right. This is what's going to go on inside your head when you're actually doing this. So down and to the left and down. There you go. Once you get the hang of this, it's interesting how you can just start moving on and working at very good speeds while you're listening to music or having a conversation with friends, because this is going to become very mechanical, just muscle memory as I'm doing it now and talking to you, which means I may do a mistake because my brain doesn't what's that word? See, I forgot the word. Multitask. There you go. That's how bad I am at this thing. But once we're over this hurdle and we go this way, I'm quite excited because it seems... There you go. That's not bad. Right click, insert key, track position. Look here, it tracked a few more that way. Now one thing I need to focus your attention on is sometimes when you do the insertion of the key and it does the bidirectional tracking, some of the frames that previously looked perfect, they may change slightly. So the fact that we've been through certain frames and we are happy with them doesn't mean that they won't change. Just be aware before you move to another feature of your track. Make sure that everything is in place, and you can just do that by scrubbing through or playing your movie with your tracker locked, and you'll see any jumps and so forth. So let's go here, right click, insert key at track position. It's going to do its calculations. Again, we have this movement and then it recovers. You can see it both in the numerical expression of the arrow where it's a bit more orange and visually. Right click, insert key. So now we've isolated this area in here, which we are going to correct. This looks good, good. Oh, there you go. So here I'm going to insert the key and move there, and now I'm going to move it down manually first, and now use my arrow keys. So back, front, bit to the left, back, front, perfect. Now it goes down to the right, back, front, down, back, front, perfect. Very good. A bit up and a bit to the left, maybe a bit down. You can change your mind, you're allowed to do that, it's your prerogative. Excellent. I think this goes a bit down, but I think it's so small it doesn't make a difference. Now you can see that the lock view was jumping a bit. This is something that happens rarely, but don't be alarmed. Just go back and forth a few times and it will correct itself. Fantastic. Let's go here and let's move. We've only got a few frames to go, so this looks good. Go here, insert key track position, and look at that. It created by that little limitation I told you, an automatic track somewhere in your scene. The good thing about that, it's benign. It's benign. You just select it and you delete it. You can even select it there. So don't worry about it. If these ghost trackers appear, they're all good. There you go. So let's go back. Let's zoom in and let's play this. And you will see that the feature is locked to the track. And unless we see some extraordinary jump or something that will pop out quite obviously, that means the track is nearly perfect. There you go. So this is the process of a case of a difficult feature to track. You can be even more accurate if you're willing to go and keyframe manually most of the frames. And to be honest with you, but believe me, you don't have to. If you want to, though, no one's stopping you from that.